the general statement, the statement of Rolle's minimal theorem is let f of x be a function such that this function is a real valued function. Generally, we have to mention from f from closed interval a comma b to r be a real valued function, and such that first condition is it is continuous in closed interval a comma b, and it should be differentiable in open interval a comma b, and f of a equals to f of b. If these three conditions satisfied, then we can say that Rolle's theorem is applicable. Then there exists at least one point C belongs to C in open interval a comma b, or C belongs to open interval a comma b, such that f dash of C is equals to 0. That means if these three conditions satisfied, then we can say this Rolle's theorem is applicable. Whenever Rolle's theorem is applicable, using the Rolle's theorem, we can say that at least one point C in the open interval a comma b, this condition will satisfy. This is a Rolle's theorem statement. But now they will give us how verify Rolle's theorem for the problems. They'll mention verify Rolle's theorem. Whenever they mention verify Rolle's theorem, few points we have to remember. Algebraic function. One second, otherwise. Algebraic function is continuous everywhere. Every algebraic function is continuous everywhere. Every algebraic function. So I'm mentioning here it is function like a small table, and discussing about continuous, and also discussing about differentiation. Okay, so whenever we take this, every algebraic function continuous everywhere and also continuous or differentiable everywhere. And next I'm taking exponential function. Every exponential function is also continuous everywhere and also differentiable everywhere. And now I'm taking logarithmic function. Every logarithmic function is continuous everywhere, but differentiation only in particular intervals. Only in particular intervals it is differentiable. Okay, next one is last one, trigonometric functions. In the trigonometric functions, I am taking few trigonometric functions. Especially, I am taking here sin x and cos x. These two functions are, sorry, this is cos x. Cos x. These two are continuous everywhere and also differentiable everywhere. These two, which are the two sin x and cos x functions, are continuous and differentiable everywhere. But when we take a few trigonometric functions like tan or cot, the remaining trigonometric functions are continuous only in some particular intervals. Continuous only in some particular intervals. Same manner, differentiable also only in some particular intervals. Only some particular intervals. So these are the things. So this is applicable for continuous as well as differentiation. So a very important point, this one only we have to remember. what are the trigonometric functions? For example, if when I take a problem, I'll explain it, no problem. So now coming to the problem of this function, this problem here, whenever I'm taking here, verify Rolle's theorem for the function f of x equals to sine x by e power x or e power minus x into sine x in the interval closed interval 0 comma pi. Whenever they are asking this, first we have to understand that what is the given function f of x. F of x is the combination of a exponential function and a trigonometric function. Especially the trigonometric function is sine x function. So e power x is exponential function is continuous everywhere and also differentiable everywhere. Sin x function is also continuous everywhere and also differentiable everywhere. That only we discussed in our previous few minutes back. So since sin x and e power x both are continuous functions, then we can say their product or sin x by e power x is also continuous in everywhere, in any interval, but especially in our interval it is continuous, we have to mention. So condition 1 satisfied. The second condition is we have to check about the differentiation for differentiable. So we know that sin x and e power x are differentiable everywhere, especially these are differentiable especially in this interval, open interval 0 comma pi. Their division is also, that is a f function, is also differentiable in open interval 0 comma pi, clearly. So now substitute try to substitute f of x is equals to a. What is a value? Generally we have to take this as a and this as b. A is equals to 0, substitute a equals to 0, then f of 0 is equals to sine 0 by e power 0. Sine 0 is 0, 0 by e power 0 value is 1, so 0 by 1 is 0. Got it. Next, f of b. F of b is nothing but pi here. F of pi equals to pi by sine pi, sorry, sine pi by e power pi. So sine pi is equals to 1, e power pi, e power, sorry, sine pi is 0, sine pi is 0, e power pi is don't know about it, so 0 by e power pi is also 0. So getting this value is also 0. F of 0 value is 0, f of pi value is 0, then we can say that f of 0 is equals to f of pi. The third condition of our Rolle's theorem satisfied. Then thus all the three conditions of Rolle's theorem are satisfied. Hence, what can we say using the Rolle's theorem? Then there exists at least one point C belongs to open interval a comma b such that f dash of c equals to 0. This is the statement we have to write. But they asked us in the problem verify. We can say by using Rolle's theorem this can happen, but we have to check it. We have to check it whether it is happening or not. For that, we have to find f dash of x. We have to take f dash of c equals to 0. For finding f dash of c, first finding f dash of x. What is f of x? F of x is equals to sine x by e power x. So differentiation of f dash is nothing but right hand side also we need to take the differentiation. So we need to take the differentiation is nothing but differentiation of u by v. Differentiation of u by v is nothing but differential uv whole dash is equals to, the formula is v into u dash minus u into v dash by v square. So all these are, I am using annotations. If you want any screenshots, then you can take. Whenever I am writing it on the notebook, then that will not erase, that I can send it. So this is, I am recording the recording. If you want, I can upload and I can give you to you the link. That's enough. So v u dash minus u v dash. So v is equals to e power x. So what we'll get here, differentiation of f of x, that is f dash of x is equals to v. V is nothing but denominator e power x into differentiation of u, nothing but sin x differentiation is cos x, minus u into nothing but sin x into differentiation of v. So denominator e power x differentiation is e power x by v square, e power x whole square. So we can take e power x common in the numerator. Then if I take e power x common, we'll get cos x minus sin x by e power x whole square. That e power x and the square gets cancelled, we'll get e power x. So this is our f dash of x. This is our f dash of x. That one only we mentioned. So now we need to take f dash of c equals to 0. F dash of c is nothing but what is that? In place of x, substitute c, cos c minus sin c by e power c is equals to 0. That implies cos c minus sin c is equals to 0. Take sin c to right hand side, then we'll get cos c equals to sin c. Bring cos c to also to right hand side, but it is in the product form. So we'll get 1 is equals to sin c by cos c is nothing but tan c. Tan c is equals to 1. From this we can say that c is equals to tan inverse of 1. Tan inverse of 1 is nothing but pi by 4, that is 45 degrees. So pi by 4, check pi by 4 is available in the open interval 0 comma pi. It will be available on 0 to pi. Yes, it is available. So c is equals to 45 degrees is exists in our interval. So at least one of the value of c must exist in our interval. Hence Rolle's theorem verified. Rolle's theorem verified. So I'm going to clear the screen. This is the case. This is the case. Now going to take tan x function. Verify Rolle's theorem. One second. Verify Rolle's theorem. They're asking that verify the Rolle's theorem for the following functions. So the first function is tan x function. As I mentioned, tan x function is not continuous everywhere. It is not continuous everywhere. Tan x function is discontinuous at some points. So we'll get the graph of tan x will be like this. One second. We'll get the graph of tan x will be like this. So the graph of tan x will be like this. We'll get, one second. So tan x graph వచ్చేసి మనకి ఇలా వస్తుంది. This is x-axis. If I take this one, we'll get the tan x graph will be like this. Okay, so ఇలా వస్తుంది. ఇక్కడ వచ్చేసి this is tan x, x is equals to 0. At this is pi by 2 and this is pi, and like that this is 3 pi by 2. Now same manner we'll get here like this the graph. Okay, so here it is minus pi by 2, minus pi by 2. And one more point is, so if we observe pi by 2, we'll get straight line like this, or like dotted lines. 3 pi by 2 like this we'll get. So at these dotted lines the tan x graph will not have any continuity. Okay, so other than these points, that means tan x is discontinuous, tan x is not continuous, at x equals to plus pi by 2 comma minus pi by 2. So plus or minus pi by 2, plus or minus 3 pi by 2, plus 3 pi by 2 minus 3 pi by 2, plus 5 pi by 2 minus 5 pi by 2, and so on. At all these points it is not continuous. Whenever it is not continuous, for example in the given interval, if at least one of these points exist in the given interval, at least one of the point exists, then it is not continuous. Now, if you observe, if we observe, given here at my hand, given f of x equals to tan x, given f of x equals to tan x in the interval 0 comma pi. But in the interval 0 comma pi, do we have plus pi by 2? Yes, x equals to, oh, 1 second. So x equals to plus pi by 2. X equals to plus pi by 2 existing in our interval, closed interval 0 comma pi. But at this point, x equals to pi by 2, we are mentioning that it is discontinuous. So with this, we can conclude that f of x equals to tan x is not continuous at x equals to pi by 2. So it is not continuous, especially in the given interval 0 comma pi. So the first f of x is discontinuous at x equals to pi by 2 and it is not defined there. Thus, condition number 1 of the Rolle's theorem not satisfied. Then we, if condition 1 not satisfied, then not need to check about the condition 2 or 3. So I can go directly to the Rolle's theorem cannot be applicable. So we cannot apply Rolle's theorem. Okay, same manner, if I'm taking f of x equals to 1 by x square. So in this interval, we have to check whether it is continuous or not. For example, I'm taking x equals to 0. When I take x equals to 0, when we take x equals to 0, then we cannot identify. When we take x equals to 0, what is f of 0 value we'll get? F of 0 is equals to 1 by 0 square. Nothing but 1 by 0. 1 by 0 is equals to infinity, undetermined. That means does not exist, infinity. If we are getting f of x value is infinity at some x value, at that x value is existing in our interval, then it is also not continuous. ఏ ఎక్స్ వాల్యూ దగ్గర అయితే ఇన్ఫినిటీ వస్తుందో ఎఫ్ ఆఫ్ ఎక్స్ వాల్యూ, ఆ ఎక్స్ వాల్యూ కనుక మన ఇంటర్వల్లో ఉంటే అప్పుడు కూడా given function is not continuous in this interval. So as we discussed, f of x equals to 1 by x square is not existing at x equals to 0. So f of x is discontinuous at x equals to 0. Exist అవ్వట్లేదు అంటే discontinuity అవుతున్నట్టే. So first condition itself not satisfied, hence Rolle's theorem is not applicable. So these are the points. And one more problem is there, like modulus of x. If we take modulus of x, f of x equals to mod x in the interval, for example, they are giving -1 comma +1. Continuous అవుతుంది. The graph of this thing will be like this. ఇలా V shape లో వస్తుంది. Mod x, f of x equals to mod x will be like this. But we know that in our intermediate, at sharp edges, the function is not differentiable. ఇక్కడ గ్రాఫ్ మొత్తం ఇట్లానే కంటిన్యూ అవుతూ వస్తుంది ఇట్లా. It is continuous అని చెప్పొచ్చు. But when it comes to at sharp edges, it is not differentiable. It is not differentiable. So modulus of x is not differentiable at x equals to 0, but that 0 is existing in the open interval. X equals to 0 belongs to open interval -1 comma +1. సో ఈ ఇంటర్వల్లో ఉంటుంది కాబట్టి it is not differentiable. Which one? F of x equals to mod x is not differentiable in the interval open interval -1 comma +1. Second condition fail అయింది కాబట్టి differentiation does not exist. Then at least one condition fail అయినా మనం నెక్స్ట్ కండిషన్కి వెళ్ళాల్సిన అవసరం లేదు. Rolle's theorem is not applicable. Rolle's theorem is not applicable. These are the cases. Now going to the Lagrange's mean value theorem. Lagrange's mean value theorem, Rolle's mean value theorem, both are similar, but only one point is different. In the Rolle's mean value theorem, we will have the first condition is let f of x be a function defined from f from closed interval a comma b to r, such that first condition is continuous in closed interval a comma b, and the second condition is differentiable in open interval a comma b, and the third condition is the Rolle's theorem, f of a equals to f of b. That condition will not exist here. then only two conditions we'll have in Lagrange's mean value theorem. Then there exists at least one point C belongs to open interval a comma b such that in Rolle's theorem f dash of C equals to 0, but here f dash of C equals to f of b minus f of a by b minus a. F dash of C equals to f of b minus f of a by b minus a. This is the thing. So same model we have to do, but f of a equals to f of b not required for us. So they are asking that verify Rolle's theorem for this problem. Given function f of x is a polynomial function. So as I mentioned in the before we start this concept, this is a algebraic function. Algebraic function is a algebraic function or polynomial function. Algebraic function is continuous everywhere and differentiable everywhere. Okay, so in particular we have to discuss about it is continuous in the given interval closed interval 0 comma 4, and it is differentiable also differentiable in open interval 0 comma 4. So two conditions satisfied, then we have to go for, if these two conditions satisfied, then we have to go for our uh, Lagrange's mean value theorem is applicable. By using the Lagrange's theorem, then we can say that then there exists at least one point C belongs to open interval 0 comma 4 such that f dash of C equals to f of b minus f of a by b minus a. That's enough. But they mentioned verify. Whenever they mentioned verify, then we have to take that f dash of C equals to f of b minus f of a by b minus a. So this is f of x. Find out f dash of x. F dash of x equals to differentiation of x cube is 3x square minus differentiation of x square is 2x minus differentiation of 5x is 5 plus differentiation of 3 is 0. So in this we have to substitute, we have to take f dash of c. That means 3c square minus 2c minus 5 equals to f of b. B is a closed interval a comma b. So a value is 0, b value is 4. F of 4 minus f of 0 by 4 minus 0. If we do simplification, then we will get like this. We'll get like this. So if we observe, this is the thing, we'll get it. So take a C also to, oh, sorry, 7, which is existing right hand side, also take to left hand side, it will become minus 7 minus 5 is minus 12. So we have to find the roots for this. So 3 12s are 36. Product is 36 and their sum is, sorry, product is minus 36 and their sum is minus 2. So only 9 fours are 36 is possible, 12 threes are possible, but their sum will not come as minus 2. So using the formula of root of, sorry, plus or minus b plus or minus root of b square minus 4ac by 2a, using that formula, then getting the values are like this. C is equals to 1 plus or minus root 37 by 3. So first I am taking 1 plus root 37 by 3. So root 36 is 6. Root 37 is also I am treating as 6. So if I take this is a 6 point something, okay, treat as 6. 6 plus 1, 7. 7 by 3 is nothing but 2.33 approximately. Then same manner 1 minus root 3 by 3, sorry, root 37 by 3. So root 37, if I take it is a 6, 1 minus 6 is minus 5, minus 5 by 3. If we take minus 5 by 3, then we'll get minus 1.66 approximately. But what is our given interval 0 comma 4? In this interval 0 comma 4, negative value will exist or not? No way to get negative value. Negative value unde chance ledu. So positive value 2.33 untunda untundi. So we can mention that 1 plus, I am not mentioning 2.33, we will mention like 1 plus root 37 by 3 lies in the open interval 0 comma 4. Then Lagrange's mean value, hence Lagrange's mean value theorem verified. This is a process. These are the problems on Lagrange's mean value theorem, but we will have a special case problems on this Lagrange's mean value theorem. So this is the problem they will give us in examination, and it is very, very important. This is a problem repeated so many number of times. Now we have to prove this one. For proving this, I'm going to take, first this function. This function I am going to take as it is. They mention using Lagrange's mean value theorem, but I am treating that they didn't mention anything. So from this, we have to understand that b minus a exists in numerator here as well as here. Both are in product only. So for eliminating b minus a, I am going to divide with the b minus a. If we divide with b minus a, then we'll get 1 by 1 plus b square is less than tan inverse of b minus tan inverse of a by b minus a is less than 1 by 1 plus a square. If we observe, this one, it looks like tan inverse b minus tan inverse a by b minus a, tan inverse b minus tan inverse a by b minus a, nothing but f of b minus f of a by b minus a. కింద b నే ఉంది మైనస్ a ఉంది అయిపోయింది. న్యూమరేటర్ లో f of b minus f of a. If I take tan inverse b is f of b, tan inverse a is f of a, then uh, what can we expect? F of x, is equals to tan f of a is tan inverse a, f of b is tan inverse b, అంటే a ప్లేస్ లో b పెట్టా, ఇప్పుడు b ప్లేస్ లో x పెట్టు. సో f of x is equals to tan inverse x. So consider f of x equals to tan inverse x. That one we have to consider. In which interval we have to consider? How it looks like here? Here it looks like as f of b minus f of a by b minus a. Already ab only is available. So we have to take the interval in closed interval a comma b. Why should we have to take only a comma b? Why can't we take b comma a? Because they mention in the problem if a is less than b. A is a lesser value than b, so that we have to use closed interval a comma b. We have to consider that. That is a very important step of our problem. So consider f of x equals to tan inverse x in closed interval a comma b. And whenever a problem like this we are considering, we can blindly write f of x is continuous and f of x is differentiable. And which method, which theorem we have to apply, Rolle's theorem or Lagrange's theorem or the next theorem? How to identify? This is in the form of the middle one, f of b minus f of a by b minus a. In place of this, we can write f dash of c in our future purpose, so that it is in the form of f of b minus f of a by b minus a. So assume that applying Lagrange's mean value theorem. So we can apply Lagrange's mean value theorem because it is continuous and also differentiable. Directly, you don't check anything. So clearly f of x is continuous in closed interval a comma b, and f of x is differentiable in open interval a comma b. Then there exists at least one point c belongs to open interval a comma b such that, so ఏంటి మన condition, c belongs to open interval a comma b such that f dash of c equals to f of b. What is f dash of c? F of x అని అనుకున్నాము tan inverse x. Then what is a f dash of x becomes tan inverse x. Differentiation is 1 by 1 plus x square, but f dash of c is 1 by 1 plus c square is equals to f of b. F of b is nothing but x place లో b పెట్టండి, tan inverse b minus f of a is nothing but tan inverse a by b minus a. This is the thing. So taking it as equation number something, 1 by 1 plus c square is equals to tan inverse b minus tan inverse a by b minus a. Whatever we have here, okay. Okay, now using our theorem statement, there exists at least one point c belongs to open interval a comma b అని చెప్పుకున్నాం కదా. c belongs to open interval a comma b ని ఇప్పుడు నేను తీసుకుంటాను. సో one second, I'm taking that c belongs to open interval a comma b here. So c belongs to open interval a comma b. Now, C belongs to open interval A comma B is nothing but C must lies in between A and B only. 1 second. So C belongs to open interval A comma B is nothing but C value will be in between A and B. So we can take that A is less than C less than B. What we got the previous equation? What is the previous equation we got? It is 1 by 1 plus C square. Okay, I'll say no problem. 1 by 1 plus C square is equals to tan inverse B minus tan inverse A by B minus A. This is the thing only we got. Now we have to get this middle one. Where is that middle one? In place of C, like this 1 by 1 plus C square. Like this 1 by 1 plus C square. Forgetting this 1 by 1 plus C square, forgetting this 1 by 1 plus C square, first C నుంచి రావాలి. From C, సికి స్క్వేర్ ఉంది, తర్వాత +1 ఉంది, తర్వాత దాన్ని డినామినేటర్లో తీసుకెళ్ళాం. సో ఫస్ట్ స్క్వేరింగ్ ఆన్ బౌత్ సైడ్, ఆల్ ద సైడ్. సో A square less than C square less than B square. తర్వాత +1 is there. So adding 1. So 1 plus A square less than 1 plus C square less than 1 plus B square. 1 plus A square less than 1 plus C square less than 1 plus B square. Okay, and then we have to take it in the reciprocal we have to take. That means we have to take it to denominator. While we take it to denominator, we will get it 1 by 1 plus A square, 1 by 1 plus C square, 1 by 1 plus B square. Like this we will get it. When we get like this, we take the reciprocal. The less than symbol becomes greater than. Why it will become like this? For example, I am taking 2 is less than 3 less than 4. Okay, then when I take 1 by 2, 1 by 3 and 1 by 4, it will become greater than. 1 by 2 is 0.5, 1 by 3 is 0.33. Check it. 1 by 2 is 0.5, 1 by 3 is 0.33, 1 by 4 is 0.25. Then if you find these things, 0.5 is greater than 0.33, 0.33 is greater than 0.25. So using this numerical values, we can get it. Now, I am writing it in the reverse direction. So what is that? 1 by 1 plus B square can be written less than 1 by 1 plus C square can be written less than 1 by 1 plus A square. But 1 by 1 plus C square is nothing but tan inverse B minus tan inverse A by B minus A. మనకి ఇక్కడ ఒక ఈక్వేషన్ రాసాం. 1 by 1 plus C square equals to tan inverse B minus tan inverse A by B minus A. I'm using this now here. So if I use it, substitute it here, then it will become 1 by 1 plus B square is less than tan inverse B minus tan inverse A by B minus A is less than 1 by 1 plus A square. Now I'm multiplying with B minus A all the sides. Then B minus A by 1 plus B square less than tan inverse B minus tan inverse A by B minus A into B minus A. Denominator B minus A, numerator B minus A gets cancels. Then less than B minus A by 1 plus A square. So this one we will get it. So check it, what we have to prove. This one only we have to prove here. So 1 second. Check here. B minus A by 1 plus B square is less than tan inverse B minus tan inverse A is less than B minus A by 1 plus A square. Then why I have written earlier, why I have written earlier, like from the problem, why I have written like from the problem, why should we divided with b minus a for identifying, for identifying f of x function and its interval. For considering this, I took it. That is a process. Okay, now this is a thing we completed. Now what they are saying that, and deduce the following things. Forgetting these are the things, we have to substitute in place of a and b some values. What are the values we have to substitute in place of a and b? That is important for us. For identifying that, what we have to substitute in place of a and b, I'm going to rewrite what we have to show that first one is first one we have to show that pi by 4 plus 3 by 25 is less than tan inverse of 4 by 3 is less than pi by 4 plus 1 by 6. This one we have to get it. For getting this, pi by 4 is there. Both here and here, both are in addition. Here pi by 4, here pi by 4, both are in addition. So I'm going to subtract with pi by 4. I'm going to subtract with 5 by 4. Then we'll get 3 by 25, because we subtracted, less than what we'll get here, tan inverse of 4 by 3 minus pi by 4, less than pi by 4, subtracting with pi by 4 gets cancelled, then we'll get 1 by 6. Then in the next step, we are going to write 3 by 25 is less than tan inverse of 4 by 3 minus pi by 4 can be written as tan inverse of 1. Pi by 4 can be written as tan inverse of 1 is less than 1 by 6. Now, if we observe here inside the brackets, that's the middle one, this point, this part, if we observe tan inverse b minus tan inverse a, if we feel it is as tan inverse b minus tan inverse a, what is the thing we have to consider a? So from this, put a equals to 1 and b is equals to 4 by 3. In which equation? In b minus a by 1 by 1 plus b square is less than tan inverse b minus tan inverse a, less than, in that equation. What is that equation? In which equation b minus a by 1 plus b square is less than tan inverse b minus tan inverse a is less than b minus a by 1 plus a square. In this equation, substitute a equals to 1, b equals to 4 by 3. Then again, we will get సబ్స్టిట్యూట్ చేసి సింప్లిఫై చేస్తే మరలా మనకి ఈ ఈక్వేషనే చూపించాలి. ఈ ఈక్వేషన్ చూపించే బదులు ఏం చేస్తామంటే ఇలా చూపిస్తాం, అయిపోతుంది. అంటే మీరు మనము ఏ ప్లేస్లో 1, బి ప్లేస్లో 4 by 3 సబ్స్టిట్యూట్ చేస్తే దీని వాల్యూ వచ్చేసి ఎంత రావాలి? 3 by 24 రావాలి. దీని వాల్యూ వచ్చేసి 1 by 6 రావాలి. అలా వచ్చినాయి అంటే దెన్ హెన్స్ proved our first condition. Same manner we have to go for second condition. Second condition కూడా మీరు ట్రై చేయండి. So this is a one problem which is very very important and biggest one. Now here if we observe that, if we observe this one, then what can we assume? What can we assume? They are saying that here I am mentioning problem. I'm going to write the problem here. So show that for x greater than 0, 1 plus x is less than e power x is less than 1 plus x into e power x. So we have to show this. For showing this one, we have to consider f of x function and interval. This is inequality. For considering that, please try to understand that plus 1 is here, plus 1 is available here, also plus 1 is available. So subtract with 1, That means 1 plus x minus 1 becomes x less than e power x. We are not having any 1 here, so we'll get minus 1 less than x into e power x subtracted with the 1. I didn't mention on paper subtract with 1, so that you people you can understand and write it on paper, like subtract with subtract 1, subtract 1, then we'll get it. Now check here, x is in product, here also x is in product, so can I divide with x? Divide with x, divide with x. When we divide with x, then we will get it like 1 is less than e power x minus 1 by x is less than e power x. So we have to get here, this should be in functions of f of b minus f of a by b minus a. How can we get it? That is important. Okay, that is important. The thing is, e power x we will write as it is minus 1 can be written as e power 0, and denominator x can be written as x minus 0, so no change in that. So 1 is less than e power x minus e power 0 by x minus 0 is less than e power x. Now if we understand and we observe it carefully, we observe this carefully, f of b minus f of a by b minus a, f of b is equals to x minus f of a is equals to 0, and f of x equals to e power x. So consider f of x equals to e power x in closed interval 0 comma x. Already we discussed f of x is a continuous function and it is differentiable function everywhere. Then Lagrange's mean value theorem, two conditions satisfied, then Lagrange's mean value theorem is applicable. Then there exists at least one real point c belongs to open interval 0 comma x such that f dash of c equals to f of b minus f of a by b minus a. F dash of c is nothing but e power c, so nothing but this one only will get it. So now we have to get e power c. For getting e power c, using our discussion, we have to get the middle term is e power c. So here there exists at least one point c belongs to open interval a comma b. What is a comma b? Here it is, c belongs to open interval 0 comma x. That means 0 less than x less than 0 less than c less than x. Now we have to get e power c. For getting e power c, apply exponential on all the sides. E power 0 less than e power c less than e power x. But what is e power x? E power c we discussed here. What is e power c? E power x minus 1 by x. Okay, this one. Now we'll get 1 is less than, in place of e power c we can write e power x minus 1 by x is less than e power x. Check our previous step, this one only we got it. దీని ముందు స్టెప్ 1 is less than e power x minus 1 by x is less than e power x, అదే వచ్చింది కదా. యాక్చువల్గా మనం ప్రూవ్ చేయాల్సింది ఇది కాదు, we have to prove this one. Actually we have to prove this one, but for identifying the function and the interval, ఇది మొత్తం కూడా రఫ్ వర్క్. లేదా for instead of proving this, it is enough to prove that this one, it is enough to prove that 1 is less than e power x minus 1 by x is less than e power x. Check, that one only we prove, hence proved. That is that are the special cases of Lagrange's mean value theorem. Refer the textbook, you will have more number of examples on this, so you can get some idea. Same manner, I'll go a little bit fast on the next theorem, Cauchy's mean value theorem. Cauchy's mean value theorem. Cauchy's mean value theorem and Lagrange's mean value theorem both are same, but Cauchy's mean value theorem we are applying for two different functions. Apply Lagrange's, okay, just assume like f function. F is a function from closed interval a comma b to r. F of x is f is continuous and f is differentiable. Okay, and same manner, taking one more function, g function, g is also continuous, g is also differentiable. Then the third condition we are going to get is g dash of x is not equals to 0 for any x. మన ఇచ్చిన ఇంటర్వల్ ఏ కామా బిలో ఏ ఒక్క ఎక్స్ వాల్యూ తీసుకున్నా కూడా జీ డాష్ ఆఫ్ ఎక్స్ వాల్యూ 0 అవ్వకూడదు. దట్స్ అ కండిషన్. అది కూడా మనం ప్రూవ్ చేయాల్సి ఉంటుంది. దెన్ దెర్ ఎగ్జిస్ట్ అట్లీస్ట్ వన్ పాయింట్ సి బిలాంగ్స్ టు ఓపెన్ ఇంటూ ఏ కామా బి సచ్ దట్ ఎఫ్ డాష్ ఆఫ్ సి బై జీ డాష్ ఆఫ్ సి ఈజ్ ఈక్వల్స్ టు ఎఫ్ ఆఫ్ బి మైనస్ ఎఫ్ ఆఫ్ ఏ బై జీ ఆఫ్ బి మైనస్ జీ ఆఫ్ ఏ. సో ఇవి ఎట్లా చేయాలి అంటే ఇంకా మనకు తెలిసిందే, ఎఫ్ ఆఫ్ ఎక్స్ జీ ఆఫ్ ఎక్స్ కంటిన్యూస్ అవుతుందో లేదో చెక్ చేయాలి. ఎలా చెక్ చేస్తాం? మనకు ఆల్రెడీ డిస్కస్ చేసిన కేసెస్ని బేస్ చేసుకొని ఎఫ్ ఆఫ్ ఎక్స్ అండ్ జీ ఆఫ్ ఎక్స్ బోత్ ఆర్ కంటిన్యూస్ బికాస్ దట్ ఆర్ both are polynomial functions, okay, or it is continuous, and we have to find out f dash of x and also g dash of x. మనకు కూడా కావాల్సి ఉంటుంది కాబట్టి ఫైండ్ అవుట్ చేస్తాము. దీస్ థింగ్స్ విల్ ఎగ్జిస్ట్ ఇన్ ద గివెన్ ఇంటర్వల్ ఏ కామా బి. ఎందుకు ఎగ్జిస్ట్ అవుతుంది? బికాస్ ఏ బి వాల్యూస్ ఆర్ గ్రేటర్ దాన్ 0. బోత్ ద వాల్యూస్ బోత్ ఆర్ గ్రేటర్ దాన్ 0. If for example the interval is -1 comma +1, then it is not continuous, it is not differentiable also. So then Cauchy's theorem does not applicable for this. So third condition we have to check, g dash of x is equals to 0 or not. So for which values of x this total function will become 0? This total function will become 0 whenever denominator equals to infinity. Whenever denominator is infinity, that is 1 by infinity is equals to 0. So when for which values of x denominator will become 0? Whenever x is equals to infinity. Whenever x is equals to infinity, the denominator total fraction becomes 0. But x equals to infinity does not exist in our interval. So we can say that clearly g dash of x is always not equals to 0. Not equals to 0 for all x in closed into open interval a comma b. Then all the three conditions are satisfied. The conditions of Cauchy's minimal theorem are satisfied on closed interval a comma b, sorry, open interval a comma b, such that then there exists at least one point c belongs to open interval a comma b, such that f dash of c by g dash of c equals to f of b minus f of a by g of b minus g of a. Now substitute f of b value, f of a value, g of b value, g of a value, and doing simplification. Then ఇక్కడ మనకి డినామినేటర్లో 1 by root b minus 1 by root a ఉంది. Take the LCM here. Then we'll get root b into root a, numerator part of denominator. Denominatorలో numerator part root a minus root b గా మారుతుంది. ఇక్కడ రూట్ బి మైనస్ రూట్ ఏ ఉంది, ఇక్కడ రూట్ ఏ మైనస్ రూట్ బి ఉంది. మైనస్ కామన్ తీసేసి క్యాన్సిల్ చేసేస్తాం. సింప్లిఫై చేస్తే మనకి ఫైనల్గా స్క్వేర్ రూట్ ఆఫ్ ఏబి ఈజ్ ఈక్వల్స్ టు సి. సో మనం ఒక వాల్యూ తీసుకున్నాం 1,2. ఒక ఇంటర్వల్ 1,2లో స్క్వేర్ రూట్ ఆఫ్ 2 1 into 2 ఎగ్జిస్ట్ అవుతుందా లేదా? రూట్ 2 ఈజ్ నథింగ్ బట్ 1.414. 1.414 will exist in the interval open interval 1,2. Hence Cauchy's minimal theorem verified. This is the process. So Maclaurin's theorem, Maclaurin's theorem is f of x equals to, statement is not required, the formulas we required to find. F of x equals to f of 0 plus x into f dash of 0 plus x square by factorial into f double dash of 0 plus x cube by factorial into f triple dash of 0. That is a Maclaurin series expansion of f of x function, or అలానైనా చెప్పచ్చు, లేదా టేలర్స్ థీరం, Taylor's mean value theorem statement, or Taylor series expansion of f of x at x equals to 0 అని చెప్పచ్చు. Taylor series expansion of f of x at x equals to 0 అని చెప్పచ్చు. Okay, so this is very important formula. Now they're asking that I'll show one problem on this. Okay, I'm explaining here e power x. So I'm explaining here e power x. For the namesake, I am taking easy problem that you people can understand easily and practice more number of problems on this. So find the Maclaurin series expansion of e power x. For finding the Maclaurin series expansion of this e power x, so they are giving that f of x equals to e power x, f of x equals to e power x. Okay, now what is the Maclaurin series expansion? F of x equals to, the formula is f of 0 plus x into f dash of 0 plus x square by factorial 2 into f double dash of 0 plus x cube by factorial 3 into f triple dash of 0 plus and so on. Now we need to find all these values. What are the values we require to find? Here we need to find these values. One is where is my screen? Here we need to find f of 0, f dash of 0, f double dash of 0, f triple dash of 0. For finding these values, first we need to find okay, what are the values we require? F of 0, and also we need to find f dash of 0, and also we need to find f double dash of 0, and also we need to find f triple dash of 0. For finding these values, first we need to find the corresponding functions. That is, we require to find f dash of x, we require to find f double dash of x, and also we need to find f triple dash of x. Okay, now what is f of x? F of x equals to e power x, whatever the given function they mentioned us, that we have to consider as f of x, e power x. What is f dash of x? Is all differentiation of e power x is e power x, again differentiation is e power x, again differentiation is e power x. So now substitute in these functions 0. So what will get? E power 0. E power 0 is nothing but 1. Same manner, f dash of 0 is also e power 0, is also 1. F double dash of 0, nothing but f double dash of x we required, which is e power x. F double dash of 0 is also e power 0, is 1. So this one also will become 0. Substitute all these values like this. How many number of terms we have to find? That is depends upon your wish. You can take any number of terms, depends on your choice, but minimum 2 to 3 terms we have to get non-zero terms. ఇక్కడ మనం ఎఫ్ ఆఫ్ ఇక్కడ అండర్లైన్ చేశాం కదా, ఇందులో మినిమం 2 టర్మ్స్ అయినా నాన్ జీరో టర్మ్స్ వచ్చేంత వరకు differentiation continue చేయాలి. Now substituting all these values in this, so all the values are 0 or 1 only. So now f of x, left hand side is f of x. F of x is nothing but e power x is equals to f of 0 is 1 plus x into f dash of 0 is also 1 plus x square by factorial 2 into f double dash of 0 is also 1 plus x cube by factorial 3 into f triple dash of 0 is also 1 plus ఇంకా ఫైండ్ అవుట్ చేస్తే నెక్స్ట్ టర్మ్కి వెళ్తే x power 4 by factorial 4 into fourth derivative of f of 0 is 1 plus and so on. Now on simplification we'll get e power x equals to 1 plus x square by factorial 2 plus x cube by factorial 3 plus x power 4 by factorial 4. But do we got do we identified the fourth derivative of x? No, we didn't identify, but still we are writing it. So this is a Maclaurin series expansion of e power x function. Maclaurin series expansion of e power x function. Same manner, they may ask, find the Maclaurin series expansion of f of x at x equals to sin x or cos x or sin hx or cos hx. And there are 2 more formulas. I'll just give you briefly how to get it. So I'm taking here f of x equals to f of 0. Sorry. Control C. Okay, for example, if we are getting these are Maclaurin series expansion of f of x at x equals to 0, or we can mention it as Taylor series expansion of f of x at x equals to 0. But they can ask, find the Taylor's series expansion at x equals to a. At x equals to a. Whenever they mention at x equals to a, but this is at x equals to 0. Taylor series expansion at x equals to 0, or another name is, or we can call it as Maclaurin's expansion. Maclaurin's expansion, both are same. But whenever they are asking at x equals to a, we have to write the formula. At x equals to 0, we have to substitute x equals to a. So what is that? F of x equals to, simply we'll get f of a plus x into f dash of a plus x square by factorial 2 into f double dash of a plus x cube by factorial 3 into f triple dash of a, sorry, this is f double dash of a, and f triple dash of a plus and so on. This is the formula. Same formula I'm going to use in some more case, that it is about x equals to a. This is at x equals to a. Now they're asking, they can ask Taylor series expansion, Taylor's series expansion about x equals to a. The word about is important, not at. About is nothing but in and around of x equals to, in and around of x equals to a is nothing but the same previous formula only we will get, previous formula only we will get, but this is in powers of x. Which one? This is in powers of x. But here, in place of x, we will get x minus a. In place of x, we'll get x minus a. So f of x, f of a plus, in place of x, we have to take x minus a into f dash of a plus x minus a whole square by factorial 2 into f double dash of a plus x minus a whole cube by factorial 3 into f triple dash of a. Like this we can continue. So these are the three formulas. Please remember carefully. One formula, Taylor series expansion at x equals to 0. Another formula, Taylor series expansion at x equals to a. And another formula about x equals to a. Whenever at x equals to 0, x equals to a, then we'll get the expansion will be in functions in powers of x. But whenever about x equals to a, we'll get in powers of x minus a. The process will be same like our previous. మనం ఇందాక ఎట్లయితే డిస్కస్ చేసామో అదే విధంగా మనకి ఇక్కడ వస్తాయి. Now here I'm taking two functions. Let u is in functions of x and y variables, v is also in functions of x and y variables, v is also in functions of x and y variables. Then we can find generally u is in functions of x and y variables, then we can find partial differentiation of u with respect to x and also partial differentiation of u with respect to y we can find. But same manner, v is also in functions of two variables, x and y variables, then we can find partial differentiation of v with respect to x and also partial differentiation of v with respect to y also we can find. But now they are going to ask us find the partial differentiation of u and v functions. Both are two different functions, both different or anything. So different functions they given. Uh, Find the partial differentiation of uv with respect to x and y variables at a time. They will ask us. In this case, we cannot do anything. We cannot do in the general way. So that we are going to write, take 2 by 2 determinant matrix. Determinant of 2 by 2 matrix. The matrix is, I'm shading with the some green color. So try to concentrate how to remember this. So first, u variable is there. I'm concentrating with u. Combination with u combination with x, so dou u by dou x, and u combination with y, dou u by dou y. That elements we have to take as first row elements. That are the elements we have to take as first row elements. What about the second row elements? Second row elements we have to take as combination with v. Whenever we take the second element in the numerator, then we will get the elements of second row. So v combination with x, v combination with y. V combination with x is dou v by dou x, and v combination with y is dou v by dou y. This is the thing. So this is whenever two functions are there, and the two functions are in functions of two variables, and this is called Jacobian. And in other words, we can write this is called Jacobian, and in another words, we can write the same thing as, or capital J of u comma v with respect to x comma y. With respect to x comma y. Jacobian of u comma v with respect to x comma y. In any manner we can mention. Now I'm going to discuss one more formula on this. That means these are two functions which are in functions of two variables. Now I'm going to discuss with three functions with uh, let u is in functions of x, y, z. Maybe v is there. V is also in functions of x, y, z. There may be a chance w is there. W also in functions of x, y, z. Then we have to find Jacobian. So j of u, v, w with respect to Jacob x, y, z variables. Nothing but we have to take here determinant of 3 by 3 matrix. What are the elements of 3 by 3 matrix? In the numerator, I am taking first element u function. U function combination with x, combination with y, combination with z. So what we will get? Dou u by dou x. That are the elements we are going to get in the first row elements of this determinant. Dou u by dou y, dou u by dou z. Same manner, taking the combination with v, taking the combination with v. So we will get dou v by dou x, dou v by dou x, dou v by dou y, dou v by dou z. Same manner, taking the next combination w combination with x, y, z. So writing that are the things as third row elements in this determinant. Dou w by dou x, dou w by dou y, dou w by dou z. Sorry, I made a mistake here. This is dou v by dou z. Okay, so after finding this partial differentiation, substitute values of dou u by dou x, dou u by dou y, dou u by dou z, dou v by dou x, dou v by dou y, dou v by dou z, dou w by dou x, dou w by dou y, dou w by dou z in this, and find the determinant of this 3 by 3 matrix. Find the determinant of this 3 by 3 matrix, then we'll get the Jacobian. For example, if this Jacobian value, that means j of u v w with respect to x, y, z, if this is equals to 0, then we can say that u v w are functionally related. Whenever Jacobian of u v w with respect to x, y, z equals to 0, then we can say that u v w are functionally related. For example, if this is not equals to 0, if this Jacobian value, then we can say that functionally independent. Whenever UVW Jacobian is equals to 0, functionally related or functionally dependent UVW variables. When the value is non-zero, Jacobian value, then we can say that UVW are functionally independent. Same case can happen even in this case. For example, if this Jacobian value is not equals to 0, then we can say that UV are independent variables. For example, if this Jacobian value is equals to 0, then we can say that UV are functionally related and functionally dependent variables. This is the concept of Jacobian. So now I am going to discuss a problem on this on Jacobian. They given here if x plus y square is equals to u function is given in terms of xy, v function is given in terms of yz, w function is given in terms of xz. So why should we have to take like this separately? U, v, w are in functions of x, y, z. Okay, I forgot to mention one point. I'll tell you later. So instead of finding this, we are going to find out one thing. That thing is here the statement of there are two properties on the Jacobian. The two properties are like this. The first property is Jacobian of if there are two functions uv with respect to xy variables multiplied with Jacobian of xy functions which are in functions of uv variables, this Jacobian will be is equals to 1. This Jacobian will be equals to 1. This is okay, one note is enough. Okay, this is very important. What they are going to do is here uv functions in terms of x and y variables. If they give uv in terms of x and y variables, then we can find Jacobian of uv with respect to x and y variables. But what they are going to do is they will give uv are in functions of x and y variables. What are that? U is in functions of x and y and v is in functions of x and y. They will give this. But when it comes to the second factor, in this case, x and y are must and should be in functions of u and v. Then only we can find this Jacobian. X and y are in functions of u and v variables. Then only we can find this Jacobian. But they will not provide x, y in terms of u and v variables. But they will ask us to find. Jacobian of x, y with respect to uv, but they will give uv in functions of x and y. Again repeating, they'll give us uv in functions of x and y. In that case, we can find the Jacobian of uv with respect to x and y. But they will ask us to evaluate Jacobian of xy with respect to uv. In this case, using this property, we can write Jacobian of xy with respect to u comma v is equals to 1 by Jacobian of uv with respect to x comma y. That means using the given uv functions, we will find our Jacobian of uv with respect to xy, and we will substitute this value here. Then we are getting our required Jacobian of xy with respect to uv. So this is important. I forgot to tell you. Okay, now check this problem. If we check this problem, then here they are giving uv w are in functions of x and y. So we can find Jacobian of uv with respect to x and y. But what they are asking us, they are asking that's reverse case. So from this Jacobian of xy with xyz with respect to uv we required. So writing it is as 1 by Jacobian of uv w with respect to x, y, z variables. So we'll find the denominator value using our process and we have to substitute. So now taking that Jacobian of uv w with respect to x, y, z, we have to take the determinant of 3 by 3. 3 by 3 determinant ఎలా తీసుకోవాలి? First u combination, dou u by dou x, dou u by dou y, dou u by dou z, that are the first row elements. ux anna, dou u by dou x anna same, uy and dou u by dou y both are same, uz or dou u by dou z both are same. Same manner, dou v by dou x, dou v by dou y, dou v by dou z, second row elements, and these are the third row elements. Now we need to find what is dou u by dou x. U is given this. Partial differentiate u with respect to x. If we partial differentiate u with respect to x, we'll get 1. Got it? Partial differentiation of u with respect to y, that is a uy. While we are taking the partial differentiation of u with respect to y, treat x and z as constants. X constant kabatti, then differentiation of x is 0, differentiation of y square is 2y. We'll get it. Next, uz required. Partial differentiation of u with respect to z, treat x and y are constants. But given u function is in terms of xy only, so u is a constant function. Differentiation of constant is 0. So that we are taking 0. Like that, finding the second row values, third row elements, and finding the determinant. Getting the value is 1 plus 8xyz. So substitute it in our formula what we mentioned. So what is that? Jacobian of xyz with respect to uv is equals to 1 by Jacobian of uv with respect to xyz is equals to 1 by 1 plus xyz. That's the thing. Now, if we observe one more problem, what they are saying that, show that the function u equals to x plus y plus z, v is equals to x square plus y square plus z square minus 2xyz, minus 2xy minus 2yz minus 2zx, then we have to show that, okay, u is given, v is given, w also given. From these three functions, we have to show that functionally related. Functionally related is nothing but Jacobian of u, v, w with respect to x, y, z. This value we have to show it is equals to 0. If it is 0, then only functionally related or functionally dependent, we can say that. So taking u, v, w and also finding Jacobian of u, v, w with respect to x, y, z. Find out చేసి determinant find out చేస్తే ఏమొస్తుందో చూడండి. Determinant find out చేస్తే 0 వచ్చింది. Then we can say that functionally related. This is the concept. And one more problem, only few points I'll explain here. The few points are here. Try to understand what we discussed. UVW ఇచ్చారు అంటే in terms of xyz, Jacobian అడుగుతారు with respect to xyz. ఒకవేళ UVW functions in terms of xyz ఇచ్చి Jacobian of xyz with respect to UVW if they asked us, then what I mentioned, find this value 1 by this value is Jacobian of xyz with respect to UVW. That's the case. Okay, UVW xyz లో ఇచ్చిన xyz లో UVW లో ఇచ్చిన చేయగలుగుతాము. కానీ here try to understand, given x plus y plus z equals to u is in terms of xyz, and here v is in terms of xyz. No, uv is in terms of yz, లేదా yz is in terms of u అని చెప్పొచ్చు. When it comes here, z is in terms of uvw. సో ఇక్కడ z is in terms of uvw ఇచ్చారు, ఇక్కడ u is in terms of xyz ఇచ్చారు. సో అది అటు లేదు ఇటు లేదు. సో మన ప్రాబ్లం మొత్తాన్ని ఒక వేలోకి రాసుకోవాలి. UVW in terms of XYZ అన్న రాసుకోవాలి, XYZ in terms of UVW అన్న రాసుకోవాలి. అలా రాసుకున్న తర్వాతనే మనం ఇది ఫైండ్ అవుట్ చేయాలి. ఎనీహౌ దే ఆర్ ఆస్కింగ్ దట్ evaluate this in Jacobian. Evaluate this Jacobian is nothing but XYZ ని UVW రాసుకోవాలి, XYZ లని UVW రాసుకోవాలి. XYZ ని UVW రాసుకోవాలి అంటే ఫస్ట్ z ఉంది, ఇది ఫిక్స్ అయిపోదాం, ఇది ఫిక్స్ అయిపోదాం. z is equals to UVW. ఓకే, ఇది ఫిక్స్ అయిపోదాం. w ఈక్వల్స్ టు UVW, సారీ z ఈక్వల్స్ టు UVW. సో z వచ్చేసింది మనకి, what is that, z is equals to UVW. ప్రొడక్ట్ ఇది. ఇప్పుడు నేను ఏం చేస్తానంటే ఈ y plus z తీసుకుంటా సెకండ్ ఈక్వేషన్. I'll take y plus z is equals to UV. From this, can I write y is equals to UV minus z? I'll replace z. UV minus UVW. Z is nothing but UVW. Fix it. So we are getting y is equals to, can I take UV common? UV, if I take common, 1 minus W. This is y. What's the first equation? X plus y plus z is equals to U. But from that, what is the yz? UV. This I'll use. X plus UV is equals to U. X is equals to U minus UV. Then x is equals to U into 1 minus. If we observe, x is in terms of UVW, y is also in terms of UVW, z is also in terms of UVW. If you want, you can check here. All these three things are in terms of UVW. So x, y, z are in terms of UVW, వచ్చేసినాయి కాబట్టి then we can find Jacobian of x, y, z with respect to UVW. That's the thing.